again to another UML tutorial, and in this tutorial I'm going to continue building on my previous two videos and show you how to use a sequence diagram as part of a robustness analysis. So what have we done so far? Let me open up the model. So far I have designed a system that stores movies, functionally designed it using a use case diagram with two features, namely add movie and show all movies. I have done a basic class diagram which details the data of the system and the basic classes involved in the system with no methods yet. And I have conceptualized the communication between classes using communication diagrams. So what is the next step? Well, I'm going to model the methods that need to be developed for the classes here using sequence diagrams. So contrary to the communication diagram, which gave me a high-level idea of how these classes communicate towards a certain goal, the sequence diagram will talk about that same communication, but then on the level of methods. Which means that after this step, my class diagram will be updated with all the needed methods, and I can actually generate my code and start developing my program. So, alright, let's create a sequence diagram first. So I go to the Model Explorer, I right click on my model, choose New Diagram and Sequence Diagram. So like with the communication diagram, I'm going to do one sequence diagram for one use case, just so well, that's actually the way it should be done, and that's also the most organized way of doing it. So in this case I'm going to do the add movie sequence diagram. So there we go. Again, let's make this a little bit smaller. Even though I'll be needing plenty of space before this is over. Alright, so again, since the communication takes place between classes, I'm going to drag all the essential classes that I'm going to need from my Model Explorer to my sequence diagram. But before I do, let's change the name of the sequence diagram. So this is the add movie scenario that I'm working on. Okay, since I already have a sequence diagram with the same name, I'm just going to call it add movie SD, representing sequence diagram. Okay, so we have, well, what classes are we going to need? We're going to need the add movies class again, which is modeled here as a lifeline. Essentially a lifeline is the class with a timeline below it, which actually represents the method calls in the sequence of method calls as they are done over time. So this is earlier in time, that is later in time. So I'm going to need my mainframe. Naturally I'm going to need my controller again. As a matter of fact, I'm going to need the exact same classes as in my communication diagram. So let's just bring that one up again. There we go. Add movies, mainframe, controller, data storage, movie as well, even though I will add that one slightly later. So controller and data storage. Where's my data storage? Here it is. Okay, like I said, I will add movie later because that's a bit of a special case. So what I'm going to do is I'm going to create a message from add movies to mainframe, which is part of my sequence of messages that needs to be done, or actually method calls in this case. I'm going to model them as a Java call, and yeah, basically, anyway, you'll see it when I do it. But before I do, I want to explain a little bit about what types of messages we have. So basically we have 4 types of message that are relevant here. We have the synchronous message. So what is a synchronous message? Well, basically a synchronous message is a method call which is made between two classes and straight away gets a result. So basically every method you create in Java is a synchronous message. A asynchronous message is basically a method call that doesn't return a result straight away, but returns a result via a callback. So it's slightly different modeled, slightly different in terms of modeling. Then we have the message reply, which is basically the output of a synchronous call. And then we have the message create, which is basically the creation of an object. And since I need to create a movie object later on, that will be done with the message create. So okay, let's get started. Well, first of all, if I'm going to do synchronous messages, I need to first create a action execution behavior on my first lifeline. This basically is used to indicate that the control of a program is at a certain point in time is with this class, because control will be passed along different classes when messages are being invoked. Okay, so I've just dragged my action execution specification to the lifeline. I made it a bit bigger. Okay, and then I'm going to do my first message, synchronous message. So I'm just going to click on my one class, then I'm going to drag to the other one, then wait for the white circle to appear, release my mouse, click again. So in this case I want to define a method that is being invoked between these two classes, so I'm going to say create new element. In this case I'm going to create the method getController. Why is that? Because the mainframe, the add movie screen, needs to use the controller in order to save data. But the mainframe has actual access to the controller. So with the getController method, the mainframe will return the controller to the add movie screen, so the add movie screen can use it to execute the data. Why am I simply not having the controller inside my actual class? Well, I will show that in a moment. Let me first create this and then add execution specification. Okay, I'll come back to this in a moment. The reason why my controller is not part of my screen is because I don't want to have a connection between every screen and the controller. This makes for bad program design. Okay, anyway, back to this. So I've created a message. First, I'm going to indicate that this is a method call, so I'm going to remove the underscore message here. So it becomes a bit like your normal Java method syntax, no parameters here. We'll add those later. And since this is a synchronous message, I need to have a reply. So I'm going to use my message reply, and I'm going to drag this from the bottom of the execution box. And then drag it here slightly lower. Click. Since I already defined a method that is being replied, I'm going to choose select existing element. getController. Okay. The only thing I'm going to do to indicate that this is a reply to a method call, I'm going to change in the properties the name of the message to getController underscore result. And now you will actually see the nice reply message. So add movies invokes a method on mainframe, synchronous method, and a reply is given. You may notice that even though I have a method call here, I don't have any parameters yet. So to add parameters and make it a full-fledged method call, I actually have to go back to my class diagram. So since the method I just defined is on the mainframe class, I need to go back to my class diagram, go to my mainframe, right click, go to filters, go to show hide contents, and you will see my message is there. So I will tick it, press OK, and now my message is there. I can basically manipulate this method just like any other method I've done in a regular class diagram. So let's just click on it and add a return type. So I'm going to go to parameters. I'm going to call my return parameter result. The direction is return. And in this case, since this method needs to return the controller, I'm going to set the data type to the actual controller class. There we go. Input parameters not required for this method. So now you can see it's added here. I save, and if I go back to my sequence diagram, it's also added here. So it should already be clear to you at this point that if you define an actual method here, it will appear in your class diagram. You can manipulate it just like any other method in your class diagram, and through all the different sequence scenarios for all the use case scenarios, actually build up a full class diagram that you can use to generate your code from. Well, that should be useful if you're a developer. Okay, so the next step in this case would be, I have my controller, so my add movies class will have to invoke the controller to save the movie. So again, I'm going to create a synchronous message. I'm going to make sure there's some space below here. So let's say over here. I'm going to drag it again, in this case to the controller. Again, wait for the white circle, release, click again, and again create a new element. In this case I'm going to call the method addMovie in line with what I have designed in my communication diagram. Then again, since the control needs to be passed from this class to that class, I need to create another action execution specification, and I can rename this method, if I can find the property, to simply addMovie. Okay, I'm not going to go clicking back and forward between my class diagram and sequence diagram all the time. Well, I think I'll do it this time, and then after that I'll just finish the diagram. So I'm going to do my message reply. As a matter of fact, before I do that, let's make this a bit bigger. I'm trying to think ahead because I'm going to have another method call here. So I'm going to make my lifelines a bit bigger, so I have a bit more space. Make the box a bit bigger. Okay, this one should be big enough now. So now I'm going to draw my reply. Then again I'm going to choose my existing element, which would be addMovie. So there we go, and it's addMovie underscore result. Okay, like I said, let's update it in the class diagram one more time. So in this case I've added a method to controller. So again, same thing, filters, show hide contents, addMovie. And again, what we're going to need for parameter in this case, I have designed the movie title and the movie year. So I'm going to say T for title, input parameter, which is a string, and my second parameter will be the year, which is a integer. Lastly, I'm going to need a return parameter just to indicate that the storing is successful, which will be of the type boolean, so boolean true or false to indicate successful, unsuccessful storage. So since my class diagram is already getting bigger, let's just give it a little bit more space. Okay, that should suffice for now. Okay, save, go back, and you will see the parameters are nicely added in proper syntax in my sequence diagram. Okay, so the controller has to create a instance of movie in order to save the movie. So again, I'm going to drag it in between here. So I'm going to use my create message in this case to indicate creating of the object. So go from there to there. The only difference is I'm going to say, since this is newly created, I'm not going to create any new element. And there we go. You will see that the lifeline immediately jumps to a lower point. Why? Because I said that this dotted line here, the lifeline, represents time. Only at this point in time does the object come into existence, so therefore you cannot have it there. This would mean that from the start of the program these objects are in existence, or created shortly after, or for the very least before this scenario. So in this case the movie must be located here. To indicate the creation of movie, I'm simply going to put the name of it to symbolize I'm invoking a constructor to do this. Okay, let's make the lifeline a bit shorter. And this one a little bit longer. Okay, so the controller, having created the object, is going to ask the data storage to save it. So again, let's drag a synchronous message, create new element, store movie. There we go, add execution behavior. We're going to rename this to store movie. I'm going to make this a little bit shorter because the reply must come in before this guy finishes executing. So message reply from there to there, using an existing element, namely store movie, and done. So change it to result. Okay, so that basically is the whole synchronous communication. So add movies will get the controller from the mainframe, then we'll use that controller to invoke add movie with its parameter. The controller will create the movie object, which will then be stored in the data storage, which will give a reply to controller, which will give a reply to add movies. Naturally, I still need to add the parameters here. So now let's go do that. So back to the class diagram. In this case, data storage has a new method. And this store movie method needs to receive a movie object. So that's a variable named m of the type movie. There we go. And naturally we want to return a boolean to indicate successfully stored or if anything went wrong. So again, add a parameter, result, boolean. There we go. Okay, lastly, since I'm now defining methods, if I prefer, I can attach the appropriate Java stereotypes. Like, for example, the Java method stereotype. I'm not going to do this because refer to my previous video on more information on that. So there we have it. There we have the basic methods in place for the add movie scenario. But we also have the show movie scenario. Okay, so let's quickly model that. I'm going to do this one a bit faster. So again, right click, new diagram, sequence diagram, show all movies, sequence diagram, and again, name the interaction. I'm going to change the name of the interaction, show all movies SD, resize it a little bit. A little bit more. There we go. Okay, once again, so which screens do I need this time? Well, I'm gonna need my show all movies screen. I'm gonna need my mainframe again. I'm gonna need my data storage because my data storage is the one that actually saves all those movies. And almost forgot the most important one, the controller. There we go. Okay, in this case I will not be needing the movie lifeline later on because the object is already existing and inside the data storage. Okay, one more time. I'm going to create a action execution behavior. And my show all movies is going to ask the mainframe for the controller object. So that's the getController method. Again, since my getController method is already defined, I'm just going to say existing element with action execution behavior. So again, I can change this to getController, and you will see the parameter is already there. Very good. Okay, then the same message reply will be given. So basically, if you have already defined your method in one diagram, you don't need to recreate it at all, because no such thing as duplicate methods. So there we go, the getController again. So show all movies will ask the controller to retrieve all movies. So get all movies in this case. There we go. Okay, I'm going to leave the parameters for what they are right now, so I will update them all in one go later. So the controller, who doesn't have the data, needs to request the data storage for this data. So in this case, I'm going to create a new movie called retrieve all movies. And there we go again. We have created a new action execution specification. So this one will be a bit smaller, this one will be a bit bigger, and this one will be the biggest. Alright, retrieve all movies. Then naturally, he's gonna reply to the controller using the method we've just created. Then he is going to, nope, not a synchronous message, send a reply back to show all movies, which again is the get all movies method. Why are you seeing the add movie method here? Because it's defined in the previous sequence diagram. So there we go. Result. Okay, so that's our basic sequence of things. So only remaining is to update the parameters. So let's go back to the class diagram. I've just now added another method to my controller. So let's show it. So get all movies will not have any input parameters because it's just retrieving of all the movies, but will have a return type of a movie array. So again, I'm going to choose movie as my data type, and I'm going to set the multiplicity to 1 ... indicating many movies can be returned, and it will be an array. This cannot be an input parameter, this should be a return parameter. I have a tendency of forgetting that. Same thing applies to the data storage. So let's bring out the method. Again, no input parameters, but there needs to be a return parameter, which has the return direction. Of the type movie. And the multiplicity is 1 ... So there we go. So now let's go back to here, and you can see it's actually included. Just to double check the multiplicity. It is set to 1, so 1 ... Okay, it's indicated here, so that means it's fine. This one, I'm not sure what happened just now actually. But never mind, let's just correct it. So also set to 1 ... Okay, never mind, the data is captured in the class diagram. Okay, so there we have it, 2 sequence diagrams. Then as a final step, let's go back to the class diagram, right click, choose Java, generate Java code, and if I modeled correctly, and that's a bit of a question, all my classes should come out with their correct methods. So there we go. So let's take a look. Well, add movies is the one class that doesn't have any methods. So let's look at the controller, add movie, get all movies, data storage, store movie, retrieve all movies, and so on and so forth. And even my movie class has all the parameters and methods. So at this point you can basically start programming. You can start implementing your features that you have designed in your use case diagram based on a code skeleton. So I hope this gave you a good idea of what a robustness analysis is like, and at the same time demonstrated the basics to you of a communication diagram and sequence diagram and how they affect the class diagram. So I hope this tutorial was useful for you, and see you next time.